Thank you for joining us today for our webinar on SimWise for Alibre. My name is Alan Wigenka. I'm from Design Simulation Technologies, and today we're going to talk about and show you the 3D motion simulation and stress analysis capabilities of SimWise that are integrated with Alibre Design. The SimWise product family consists of 3 products. SimWise Motion, which does 3D dynamic motion simulation. SimWise FEA, which does finite element analysis on Alibre parts and assemblies. And SimWise 4D, which is a combination of these 2 products that does combined 3D motion and 3D finite element analysis. Pictorially, we take an Alibre part or assembly, we transfer that information to SimWise, and from there we can go and do any of these 3 applications, motion, FEA, or the combined motion plus FEA. Why do we call it 4D? Because when we look at using loads that result from dynamic motion simulation, these loads are difficult to calculate. Typically, a prototype is built and instrumented, and loads are obtained that way. Also, peak loads do not always equal peak stresses. So you could do a motion simulation, you could look at a graph of some forces and see where that force is at a peak, and then do a finite element analysis using those loads. But what you may find is that in that particular configuration, although the loads are high, the part is designed to handle those loads in that configuration, and the stresses are low. It may turn out that the high stress condition occurs at a different position with lower loads. So in order to find out where the worst case stress condition occurs, we need to look at the full range of motion of the assembly as it moves. And this is what 4D does. It combines motion simulation and finite element analysis. And it automatically takes these boundary conditions, these loads that result from the motion, and applies them to the finite element analysis model. Motion simulation allows someone who makes moving parts and assemblies to build a virtual prototype of that design on the computer and then see how that design is going to perform. So one of the first benefits it delivers is it reduces the need for physical testing, because you can find out bad designs early in the design process and fix them before you ever build a prototype. And this helps you reduce the cost to develop a design and reduce the time it takes you to get to market. So when we do motion simulation, we calculate the displacement, velocity, acceleration, reaction forces of all the parts that are moving or that are impacted by moving parts in the assembly. And as we mentioned, we can take these forces and torques that we calculate and use them as finite element analysis boundary conditions directly. As we mentioned, it's hard to calculate the dynamic loads for use for an FEA model. If you don't do motion simulation or build a prototype and instrument it, you really do end up with an approximation of the actual loads, and with an approximation, therefore, your finite element results may also be incorrect. Some of the things people use motion simulation for are dealing with gear systems, dealing with cams. One of the things we can do with SimWise is not only can we analyze a mechanism that contains cams, but we can use SimWise to help us determine the shape a cam needs to be to give us a particular type of motion out of an assembly that's driven by a cam. Of course, we do linkages. We can use SimWise Motion to help us size motors and actuators. So with the motion simulation, we can we can describe how we want the assembly to move, what speeds and displacements we want it to achieve, and then we can find out the power that it would take in an actuator or in a motor to achieve that motion. SimWise Motion contains compliance elements, that is, things that are flexible, springs and dampers, and it allows you, of course, to visualize the motion of your moving assembly. Now, SimWise FEA is truly designed to be finite element analysis for designers. So we're trying to make it so that you don't need to be a specialist in finite element analysis to get good results out of a finite element analysis. So one of the things we've done is we allow you to add loads and restraints directly onto the geometry. So you don't need to worry about the finite element analysis mesh. With a click of the mouse, you can say, I'd like to include this part in a finite element analysis. I can even set up what's called an adaptive finite element analysis. So I can choose an error target that I would like to achieve, and the system will do what it takes to attempt to achieve that accuracy. I run the analysis, and the system will generate the finite element mesh, and it will refine the mesh in areas where it needs to be refined in order to achieve the error that I specified. And then, of course, I can look at the stress results. And during this whole process, I don't even need to see the finite element analysis mesh unless I want to. So we've got a pretty powerful 3D automatic mesh generator, and we support these analysis: linear static, modal, which is natural frequency, buckling, both steady state and transient thermal, and a combined thermal structural analysis. And we're in the process of working on frequency response analysis for release later this year. And of course, this is integrated, as we've said, with motion simulation, so that those motion loads can come directly onto the finite element analysis model. We use exclusively 10-node tetrahedral elements. We can adaptively refine the mesh. We've got different types of structural loads, different types of restraints. We have a pretty extensive material library, so you can, of course, define your own materials. You can import materials from MatWeb, which is an online material database, or from other CAD system or analysis systems material databases. And we also bring over the material from Alibre when we transfer a part or assembly. Now, Alibre materials only contain density. They don't contain any other engineering properties. But we can define those engineering properties for that material in SimWise, and then any subsequent parts or assemblies that use that material will automatically pick up those properties when they come to SimWise. We've got different types of post-processing. Some of this we'll see in the demonstration in a few moments. As I mentioned, the H-adaptive mesh refinement allows you to start with a coarse mesh. So this is an example of a mesh that's fairly coarse. The nice thing, it's easy to generate and it solves very quickly. And SimWise will look at the errors. It will calculate an error distribution in these stress results and use that to generate smaller elements in areas where there's higher errors, and it will do this repeatedly until it achieves an error criteria that you establish. So you can see we started from a very coarse mesh, and within a couple of iterations we've got a much finer mesh that achieves the particular error criteria that we've established. And the system does this automatically for you. Here's an example of loads that came over from a motion simulation. So these are dynamic loads, and they're distributed over geometry where the connections between the parts occurs. Okay, now I'd like to go and do a demonstration of these things. So here we are in Alibre Design, and I've got an assembly here. The first thing I'm going to do is let's go look at some of the finite element capabilities, and let's start by using just this simple part. Now, to transfer this part to SimWise, I simply go to the Add-ons tab, and here's a selection for SimWise, and I say export this part to SimWise, and the transfer was just that fast. If I look at this in SimWise, I can see I've got a material that I had previously defined in SimWise from Alibre, so I'm ready to go and do a finite element analysis on this part. So let's add some restraints at each of these holes. So basically I'm saying that these holes don't move, and let's add a load to this hole. So I can go and say I'm going to add this structural load, and its value is going to be its value is going to be 500 newtons in that direction. If we like, we can go and say, I'm going to include this in a finite element analysis, and here I can mesh it. I don't have to mesh it. The system will mesh it automatically if it's not meshed. And if I want to look at the mesh, I can look at it. So that's pretty coarse. Let's make a finer mesh out of that and say, show it to me again. And let's push the button, and we run the analysis. So it's a pretty simple model. The analysis was pretty quick. And here I'm looking at my stress values. I can go over here and say I'd like to see the deformed shape. And you may notice that it's kind of counterintuitive because the part's deforming not in the direction we'd expect. And that's because we also take into account gravity. So let's turn gravity off in this model and run the analysis again and look at the deformed shape. And now it looks more like we'd expect. And we could animate this. So this was a stress analysis. Let's ask the system to do natural frequency analysis, but first let's say we'd like to calculate 8 modes at this part. So we just click that button, and there we go. So this is showing the first mode, and we can animate it. We can ask it to show, let's look at a higher mode. Okay, so that's a quick introduction to the capabilities of SimWise FEA. So let's go back to Alibre now, and let's look at how we do motion simulation. first thing I want to do is I want to suppress these two parts for right now. So when I suppress parts in Alibre, they're ignored by SimWise. So this is one way that I can control what actually gets sent to SimWise from Alibre. A lot of times during motion simulation, there's only a subset of parts that move, and we don't necessarily want to transfer all the non-moving things into SimWise if they don't have any effect on the motion simulation. Now, we can see that this model, this assembly model, has a lot of mates between the parts, so it's fully constrained into something that will move correctly. So let's export this model to SimWise. And here we go. We've got our model here. Let's hide this part. Now, all the attributes that I had defined in Alibre, that is, which parts are moving, which parts are not moving, which assemblies are flexible and which assemblies are not flexible, which constraints are between parts, have all been transferred over. So these objects here in SimWise are different SimWise joints, and they came from those Alibre constraints. For instance, if I look at mate 9 and go back to Alibre, that's this mate between these two parts. Right away now in SimWise, I can click the Run button. Whoops. And what that's showing you is gravity needs to be changed to be in the -y direction. Now, when I run this, this mechanism is just falling under gravity. And it's bouncing because of the way that mechanism is working. And I believe the piston is kind of moving in through the housing a little bit. So this is not a correct motion simulation, but it's very close. And all we did was transfer this model over from SimWise. So let's go and make a change. Let's change this joint in SimWise to an actuator. So this came over as a rigid joint on a slot. That is a joint that allows two parts to slide back and forth on an axis. So let's go and change this into a linear actuator. And let's make this a length actuator. And here I could just type in a value, or I can use this button, which takes me to the SimWise function builder. So this allows me in SimWise to define a function that's going to drive this actuator. I'm going to use a step function, which says at time 0, I'm going to start at position 0, and at time 2 seconds, I'm going to move to 50. So this is going to actuate, it's going to impart this motion on this actuator. So it's a nice, continuous, smooth motion, which is always desired. Now, I've got a number of different functions here. I can also use tabular values. So I could type in different time and displacement values, and SimWise would interpolate between that, and it would show you this interpolation on the graph. I could import this data from a text file or from an Excel spreadsheet. So I've got a lot of different ways that I can impart motion into this assembly. I'd also like to mention that this formula builder applies to forces also. So I could have some kind of formula that's driving a force that acts on this model. But for the purposes of this demonstration, let's just define this actuator. Let's go and tell SimWise that I'd like to stop this simulation when the time is greater than 2 seconds. I'd like to mention one other thing. All the units come over from Alibre just the way that you've defined them inside of Alibre. So during this transfer, we tried to keep as much the same in the SimWise model as was defined in the Alibre model. You may have noticed that when these parts came over from Alibre, that the viewing orientation was exactly the same as what you saw in Alibre. All right, so now the motion simulation is set up. Let's go and run this, and we see now it's not falling under gravity. It's actually got some control to it. Let's go and add a force. And let us add this force to act 500 newtons in that direction. And let's go up here to this actuator and say I'd like to look at a graph that shows me the force that this actuator needs to produce in order to achieve the motion I want to achieve with the stresses, with the external forces that are acting on this. So now when I run the motion simulator, this graph is showing me the force that this actuator needs to produce. So this is where I could use this information to determine how big of an actuator do I need to have on this particular assembly to get the desired motion that I want. All right, let's go back to Alibre for a moment, and let's go and unsuppress these two parts that I suppressed earlier. And now we can transfer this. We can transfer this model once again to SimWise. So think about this in the case where you made a change to this design. Now you'd like to see the effects of that change on the simulation model. Well, you don't have to start over from zero. When you say transfer this to SimWise, if it sees that the model exists already, it will simply update the changes that were made to the model. So you can see that my actuator is still here, my force is still here. All we've done is we've added these two new parts that were suppressed previously. So now when I do a run, we see that this part is falling under gravity because there's no constraint, there's no joint that's holding it in place. So let's zoom in here, and I'll show you how we create joints manually. Up until this point, we've only seen joints that were synthesized from the Alibre assembly mates. But sometimes we need to add our own joints. And SimWise gives you the ability to do that quite easily. Basically, you put in what's called a chord, and this is basically a 3D coordinate system. And from this chord, I can say, I'd like to create a constraint. It's going to be a rigid joint on a slot, and it's going to be between this chord that I've selected and that second part. So I've created that joint. Now, when I run the simulation, it doesn't fall anymore. But look what happens here. This part protrudes through that part. So let's go take care of that. Let's get rid of this force, and let's pick this part and say that instead of these two parts penetrating each other, these parts are going to collide now. And SimWise has got some very good capabilities for doing contact between parts. We've got a lot of different options for the contact models that we use to address different scenarios. Here I'm going to use one called the coefficient of restitution, and I'm going to change the coefficient of restitution to 0.1. And basically this is puts an impulse between these two parts, and the outgoing velocity will be 10% of the incoming velocity. That's what the 0.1 means. So now when I run the simulation, I see, oops, okay, the contact did occur. That contact imparted a force on that part, and it pushed it through the other part because there's no contact between those two blocks. Well, let's go and do one other thing. Let's add a spring between these two parts to provide some resistance. So I'm going to create these two chords here at the corner. I'm going to select them, and I'm going to say I'd like to create a spring between these two. And here's where I can set my spring parameters. So let's make the stiffness 15, and we can also put a damping coefficient in if we'd like. So let's put a damping coefficient in. And now when we run the simulation, we see the model works kind of like we intended. If we were curious as to what kind of force that spring is undergoing, we could create a meter. And I'm not sure why we've got these bouncy things in here, but this is the force profile of the spring. Now, let's say we were interested in the stresses that are occurring in this particular part here. So let's say, well, the forces look kind of big in this position. So let's go and take a look at this part. And all I've got to do is say, well, I'd like to include that in FEA, and you see that these loads that came from the joints on the motion simulation are automatically transferred to this part. If I want, I could take a look at the mesh. Let's make it a little bit denser. All right, and then I can say, what SimWise is telling me is I don't have a valid material on this part. So this, you can see this is the material, and it said it came over from Alibre. Well, if I look at the properties that came over from Alibre, as we mentioned, only the density come over. So if I wanted, I could define additional engineering material properties, the elastic modulus, Poisson's ratio, or I could simply pick from another material I have in SimWise and say, okay, let's use that material. All right, let's move this part back into this position, and now let's do a finite element analysis, and there we go. That's what the stresses look like just in this position. So I'm only looking at a single position here. But let's go and do a combined motion and FEA. So this is going to take little bit of time because essentially I'm solving a finite element analysis at each frame in this motion simulation. So I believe we have 100 frames in this motion simulation, so we're going to do 100 finite element analysis models. We are in the process of speeding this up significantly. Something we've got planned for the next release, we would already have the stress results because we've been able to improve this analysis performance by an order of magnitude at least. But even with this slightly slower process, we are getting good information. I said we need to do 100 finite element analysis, so you've got to be a little bit careful about how detailed your model is and how many parts, but we'd like to get to the point where it would be practical to, say, do all these parts in the assembly and do them in a fairly quick amount of time. Okay, so the finite element analysis is done. One of the things I can look at is I can look at the Fda results. So this is showing me the stress results of this part. And again, I could hide all the other bodies and I could just zoom in. And we can see now as we change the position, we can see that the stresses are indeed changing. And from this, it's very easy to see where the worst case stress condition is going to occur rather than guessing. Let's go into this position and let's look at something we call isosurfaces. Yeah, let's switch to this position, which is more interesting. This is one of the Fda post-processing capabilities. So I can say, show me the isosurfaces. So this is showing us all the surfaces of the elements whose stress is greater than this value. And as I move this slider, we can see where. So we can see that it's right in those areas where the absolutely highest stress occurs, and so kind of a useful and interesting display. Now let's go back to this model, and let's just say that I want to do an H-adaptive analysis, and I want to do a maximum of 3 iterations, and I want to try and achieve a 5% error target. And I'm just going to do it in this position. So you can see, I don't know if you saw that pop up there, but it said it was refining the mesh. So it's going to do 3, so it's done 3 iterations. It's increased the nodes by 1,800%, but didn't quite achieve our error target of 5%. It only achieved the target of 5.02%, but that's close enough. And we can see we've got a much more detailed mesh, which means we have much better results. Now, I've only done this analysis at that particular frame, but now that I've got a more refined finite element model, I could rerun the motion simulation and use this model throughout the full range of the combined motion and Fda simulation. All right, well, that brings me to the end of the demonstration part. I'd just like to pop back over here and talk about a couple of more issues. The first is pricing. So we have local currency pricing for all of our SimWise products in the Americas, Europe, the UK, and Australia. And those, again, are all priced in local currencies. And all the other areas were priced in US dollars. Now, SimWise for Alibre is a special version of SimWise, and we've tried to price it closer to where the Alibre CAD product is priced, and it's basically 60% of the price of the equivalent full SimWise model. And of course, check with us for actual pricing. But in order to achieve this pricing goal, we've taken out some capabilities that are available in the full SimWise. And these are the key capabilities that SimWise for Alibre doesn't have that you could get in the full SimWise. And the first one is the ability to open files from all the different CAD systems that we support, along with Parasolid, STEP, and IGES. So the SimWise for Alibre products can only open SimWise files and ASYS SAT files, and of course they can get geometry transferred from Alibre into SimWise. So if you had, for instance, a SolidWorks model that you wanted to open and work on, you could, of course, open that in Alibre, and once it was in Alibre, you could use it seamlessly in SimWise. So there's really no restriction by not having this capability. Full SimWise has an interface with Simulink from the MathWorks for doing control system simulation. So with this capability, you could design a control system in Simulink, combine it together with your mechanical model in SimWise, and simulate the two things together. So the control system would basically control the motion model and the motion simulation. That's only available in full SimWise. Photorealistic rendering and keyframe animation we've removed from SimWise. Some of that you already have in Alibre. We've also removed external interfaces to Nastran and Atoms, and we've removed optimization that's contained in the full SimWise. Now, if you had a version of SimWise for Alibre and you wanted to upgrade to the full SimWise, you could do so just by paying the difference in price, and the full SimWise products also will transfer data from Alibre the same way that the SimWise for Alibre products do so. For those users that we have that were using the Dynamics or Simulate products for Geomagic Design, any customers who are under maintenance for those products will be automatically upgraded for free to the equivalent SimWise for Alibre product. So if you're using Dynamics and you're under a current maintenance contract, you'll be upgraded to SimWise Motion for Alibre. If you're using Simulate and you're under current maintenance, you'll be upgraded to the SimWise 4D for Alibre product. And then going forward, you would be working with us or with our resellers and would renew maintenance with us. People who have used these products in the past but for whatever reason didn't renew their maintenance and their maintenance has lapsed can upgrade by renewing maintenance with us. So this is a pretty good deal. If your maintenance is lapsed, all you got to do is pay new maintenance and you'll be upgraded to the latest products. All right, that brings me to the end of what I wanted to show you today and talk to you about today. So if you need more information, you can contact either myself or Jeff Aragati. Both our emails are here on the screen. You can go to our website, designsimulation.com, and we've also got a special solutions page under the solutions menu pick on our website for SimWise for Alibre. In the handout section of this webinar, I have placed a copy of this presentation, so everything I talked about is available there. I've also placed a copy of a SimWise brochure, and it's just to note that this is a brochure for the full SimWise product, not the SimWise for Alibre product. We're not quite finished with that brochure yet. But that's all there. And if anybody's got any questions or wants any follow-up, contact either myself or Jeff. So I very much appreciate your time today. I hope that what I showed you is some interest to you. We think we've got a great companion product for Alibre that allows you to take what you've designed in Alibre and really help answer your questions. Does it work and will it break? So again, thank you very much. More information, give us a call or send us